I'm going to start with part 2 of this Tektronix 191 oscillator, or signal generator. I'll try to get a handle on how it works first. Let's look at the power supply circuits first. There are 3 main power supplies. There's a 450 volt unregulated supply, a 6.2 volts regulated supply, and a minus 11 volts regulated supply. I'm talking in voltages measured to ground. The 450 volt unregulated supply is derived from a winding on the transformer, a bridge diode, filter capacitor, bleeder. It's nothing complicated. The plus and minus supplies are derived from a center tapped winding on the transformer, the 6 volt supply rectifier, pair of rectifiers. It generates a plus 40 volts, which is dropped by this resistor, stabilized by this Zener diode to supply 6.2 volts. The negative supply is supplied this way down here. Looks like minus 37 volts. It's dropped by this resistor, regulated by these 2 transistors to 11 volts. So we have an unregulated 450 volt supply, a semi-regulated 6.2 volt supply, and a very good minus 11 volt supply. There are 2 vacuum tubes. Each vacuum tube has a filament. There's a 12 volt winding on the transformer. Supplies one of the vacuum tubes, V94. Its only function is to light the filament of that tube. The other vacuum tube is supplied by a 12 volt winding, and that 12 volt winding supplies V10 filament, and through a dropping resistor, a 10 volt on-off lamp. Primary is switchable between 120 and 240 volts. But effectively, all this does is light the filaments and supply these 3 voltages. So the function of a signal generator is to generate a signal. Let's look at these 2 controls. Here's an 8-position switch that determines the output frequency range. For example, here it's between 0.35 and 0.75 megahertz. That selects this blue band here, tied up against the knob. And if we go clear up here, we get the shadow off of it. This says 0.35, and if we follow that down, 0.75. So we've picked this knob setting, and that gives us an output range and frequencies as shown here, and so on. Not shown here is the 50 kilohertz only output. So let's concentrate on this circuit. We have V10, which is a dual triode. Only one of the triodes is used. Pins 1, 2, and 3. The other half is not used, just sits there. This, a gain stage, and these capacitors and inductors form a Culprits oscillator. Remember that a Culprits oscillator is a gain stage. Could be a transistor, could be a vacuum tube, could be an operational amplifier. It could be a CMOS or TTL logic gate. Anything with amplification. Positive feedback is taken from the output and fed back to the input of the gain stage. In a Culprits oscillator, the oscillation frequency is determined by this tank circuit, which is a capacitor in parallel with a coil. In the Culprits system, the capacitor is split and the feedback energizes the input to the gain stage. And the center of the capacitor goes to ground or V minus or whatever common. It can be a transistor, or it can be a vacuum tube. Same split capacitor, center goes to ground, feedback comes from the output to one side of the tank circuit. The other side of the tank circuit goes to the input of the amplifier, goes to the input of the gain stage. With either one of these amplifiers, the output signal, which is taken here or here, the amplitude of this, either an RMS or peak to peak, whatever, varies more or less directly with the input voltage. If I want a bigger sine wave, I increase this voltage. So I can control the amplitude of the output by controlling the input voltage to the gain stage. As long as the gain stage is linear, this makes a damn fine sine wave. Now, if this is a CMOS gate, which is nonlinear, this will be a square wave or highly distorted sine wave. But as long as the gain stage, be it a transistor or a vacuum tube, is operated in the linear portion of its amplification range, this makes a really nice sine wave. Well, frequency is determined by the frequency selection switch. 1, 2, 3, 4, 5, 6, 7 positions. One more, 8th position here. It's shown in the schematic as being in the 8th position, which is 50 kilohertz only. As the switch selects these various circuits, here and here, here, here and here, here, so on, it selects the frequencies. It selects the frequency range. The actual variable capacitors, which are here and here. So we have the switch selecting the ranges, and then we have the variable capacitor. Here's one capacitor, here's two capacitors. Center of the capacitor totem pole is grounded. This capacitor goes to the output circuit, of the gain stage, while this capacitor provides feedback into the gain stage. So we have a nice Culprits oscillator with all these variable stages and these two variable capacitors. Remember that the output of this oscillator, which is right here, is dependent upon the voltage supplied here, which is shown here as being 150 volts. That's not always the case. Here is the other vacuum tube. 450 volt supply is only furnished one place, and that's here. These two triodes are essentially in parallel with each other. Grids are connected together. Cathodes are connected together. And the plates are connected together with current equalizing resistors. This acts as a variable resistor. The resistance of the circuit varies with the voltage applied here. So this 450 volts is measured between here and clear down here. If I drop 100 volts across this tube, that leaves 350 volts for this circuit. If I drop 300 volts across this tube, then I get 150 volts across this tube. So what I've got here is a circuit that by varying this voltage on the grid, I can control the voltage here, raising and lowering it, which allows the output signal to be varied in amplitude. So I've got this voltage, I vary it, I vary the output signal amplitude. So that oscillator explains the functions of this selector switch and this variable capacitor setting. There are two other controls. A 10-position amplitude switch and a 3-position amplitude range. The maximum output is rated at 5 volts. So if we put the switch in this position, the maximum output is 5 volts when this knob is here at 50. The minimum output in this position of the switch is a half a volt, and that occurs over here. Down here, the range is a half a volt or 500 millivolts to 50 millivolts. Again, stepping through this. This would be equal to 50 millivolts. This would be equal to 50 millivolts. And down here, we would go from 50 millivolts down to 5 volts. Spider is swinging around. How did he get back up there? So let's look, and we have a variable resistor here, the red knob. I don't know if you hear it, but makes a little click. When it's over in this position, it's calibrated. So these numbers mean something. 2 switches and a variable resistor are part of the amplitude output system. So look at this interesting string of resistors here. This end is grounded. This end is supplied with minus 11 volts. They have a string of 266 ohm resistors. from here to here. And then we have a 215 in series with a 0 to 100 potentiometer. We have a 10 position switch that rides up and down. Here it is here. This 10 position switch selects the drop across any two of these resistors. The output voltage here is coarsely selected by this 10 position switch and finally adjusted by this variable potentiometer. This 10 position switch and this variable potentiometer is this switch and this potentiometer. This reference voltage, which is selected by coarse selected by the 10 position switch, fine selected by this variable potentiometer. This reference voltage is input into this board, which is a peak-to-peak detector. The output from the oscillator is fed in here. The reference voltage is here. The peak-to-peak voltage of the oscillator output is compared with this reference voltage, which was variable. And this output voltage is created. That output voltage is fed back through these amplifying stages to vary the voltage on this. Varying the voltage on this varies the output of the Culprits Oscillator, which is here. So we have the output from the Culprits Oscillator, the output from this reference voltage, which is selectable, being fed here. This acts as a feedback circuit such that the output from the Culprits Oscillator exactly matches this voltage all the time. This voltage is selectable on the switch. Now, all of these voltages shown as samples are set with this switch in the maximum position, which provides minus 10 volts output. Which provides a signal of 10 volts peak to peak. When this output voltage, which is selected by this whole menagerie of stuff, is 10 volts, the oscillator output is 10 volts. If I lower this to 1 volt, this signal lowers to 1 volt peak to peak. It's a peak-to-peak detector and comparator. It detects the peak-to-peak voltage from the oscillator, compares it with this, outputs a different signal, which is varied by these gain stages, which varies this variable resistor setup in order to make this peak-to-peak rectified voltage equal to that. So 10 volts here, minus 10 volts actually, provides a 10 volt peak-to-peak signal. That signal is cut in half by this 50 ohm resistor and fed to this 3-position attenuator or voltage dropping device. One stage, the output from the Culprits Oscillator goes directly to the output jack. In this stage, it has one stage of attenuation and goes to the output jack. In this position, it has 2 stages of attenuation and goes to the output jack. So we have no attenuation one stage of attenuation, two stages in series of attenuation. This 3-position switch selects no stage of attenuation, one stage of attenuation, or two series stages of attenuation. Sounds complicated, but it's really not. We essentially got an oscillator, a resistance system to vary the output of the oscillator, a voltage reference developed system, a comparator, a peak-to-peak detector, and an attenuator stage. Now, as we saw in part 1, this thing does oscillate. It does vary the amplitude. It does maintain the amplitude when we go from frequency to frequency to frequency. It's just that it only outputs 1 volt peak to peak. So everything seems to be working, except we're not able to develop this voltage. It's variable frequency. We can vary the amplitude. We just can't get to 5 volts. Well, 5 volts here, 10 volts here.